This lesson we're looking at calculating unknown angles in a triangle using trigonometry. So here's our example. We know two of the side lengths, but we don't know how big theta is or how big the angle is. Alright, in this case, we know if we're finding angles, we need to use our inverse rules. So here are our three trigonometric rules, and here are their inverses. Remembering, if we are needing to separate off the angle, then our rule becomes inverse once it moves to the other side of the equation. Right, so the same 5 steps apply each time we do one of these problems. So we've drawn the triangle, now we need to label our sides as O, A and H. Here is our right angle, so here is the hypotenuse. Here is our reference angle, so here is the opposite side, and here is our remaining adjacent side. We don't need the hypotenuse today because we don't have any information about it, but we do have information about O, which is 12, and A, which is 10.4. Theta is the main important point here because we don't know what it is and we're trying to find it out. So we'll just say X for now. I don't really mind how you write it. Okay, so we need a rule with O and A in it. So we can look up here and find that tan has O and A. I don't mind if you write tan theta equals O over A first and then put the inverse rule. It's all fine. This is our inverse rule, and now we are doing the same thing. We've chosen the rule, so we are substituting in. So we don't know theta, but we do know that the opposite side is 12 and the adjacent side is 10.4. So we can simply take our calculators out and do that. So we can say here's tan, so we're going to do shift tan. And we can see that it brings up the little power of -1. So inverse tan of 12 divided by 10.4 and close the brackets, and we get 49 degrees. Okay, so same idea. Using our 3 rules, we are still going to draw the triangle, label your sides, pick out what information you have and figure out what rule you're going to need, remembering that if you're finding angles, you are using the inverse rules. Then you substitute in and solve. So nice and easy this time, there's no rearranging required.